Hi everyone, it's the Math Sorcerer here with Chegg. In this video, we're going to discuss derivatives of polynomial and exponential functions. Here are the three main formulas that we're going to use in the examples. First formula has a name, it's called the power rule. It says that d dx of x to the n is equal to n times x to the n minus 1. Basically that's saying in order to find the derivative of x to the n, you bring down the n and you subtract 1 from the exponent. The other two formulas don't have names. Second one is d dx of c equals 0, basically taking the derivative of a constant and it's saying it's equal to 0. And the last one is d dx of e to the x is equal to e to the x. It's basically saying that the derivative of e to the x is also e to the x. Let's go ahead and do an example. Find the derivative. Part A is f of x equals x cubed plus 3x squared plus 4e to the x plus 17. Let's find the derivative solution. So f prime of x, in order to find this derivative, we're basically going to differentiate each piece one at a time. So for the first term, x cubed, we'll just use the power rule. N is equal to 3 here, because that's the exponent. So you bring it down and put it in the front. And then you subtract 1 from the exponent. 3 minus 1 is equal to 2. In the second term, we have a 3 in front of the x squared. Whenever that happens, it just hangs out. If you have a constant in front of a function like that, it just stays there. We bring down the 2. We get 2 times 3 is 6, and we subtract 1 from the exponent. We get 2 minus 1, which is 1. We don't normally write the 1 there, so I'm going to go ahead and erase it. The next term is 4e to the x. So the derivative of e to the x is e to the x, and the 4 is a constant in front of the function, so it just hangs out. So we just get 4e to the x. The last term, however, is a constant by itself, and so the derivative of a constant is 0, so the answer here is 0. Now we don't normally write the 0, so I'm just going to go ahead and get rid of it. And then our final answer would be f prime of x equals 3x squared plus 6x plus 4e to the x. Part B, y equals x to the 4/3 minus x to the 1/3. Let's find the derivative solution. Because we have x to a power in both terms, we'll just use the power rule. So y prime is equal to, the exponent on the first term is 4/3, so we'll bring down the 4/3. Then we have x, we subtract 1 from the exponent. 4/3 minus 1 is 1/3. If you have a hard time with the subtraction, it's okay. Let me show you how to do it on the side. We have 4/3 minus 1. So in order to do that in your head, what you want to do is think about 1 as a number over 3. So it's 4/3 minus 3/3. And now we can subtract, because 4 minus 3 is 1, 4/3 minus 3/3 is 1/3. That's how we get the 1/3. Here we have to do it again. So we have x to the 1/3. We'll bring down the 1/3. Then we have x, and then again 1/3 minus 1. Think of the 1 as a number over 3, so 1/3 minus 3/3, and 1 minus 3 is minus 2. We get minus 2 over 3, so we get minus 2/3. The derivative would be y prime equals 4/3 times x to the 1/3 minus 1/3 times x to the negative 2/3. And when you're doing problems like this, it's just a good idea to do the scratch work on the side. If you try to do it within the problem, it usually makes it more complicated. Part C, g of x is equal to x squared times 1 minus 5x. Go ahead and work through it. Solution. Now we don't really have a rule yet for differentiating products of functions. What we're going to do in this problem is first simplify our original function. So g of x is equal to, because we have a product, let's go ahead and just multiply it through. So x squared times 1 is equal to x squared. And x squared times minus 5x is minus 5x cubed. Now we have x to a power in both terms, so we can find g prime. So g prime of x is equal to, the derivative of x squared is 2x. Just using the power rule, you bring down the 2 and subtract 1. And here we bring down the 3, and so we get minus 15x squared. So that the derivative of 5x cubed is simply 15x squared. And so finally, g prime of x is 2x minus 15x squared, and that would be the derivative in this particular example. Part D, f of w equals 1 plus w squared over w cubed. Let's go ahead and find this derivative solution. So we're going to start by trying to rewrite our function into something that is more manageable. We're looking for basically w to a power because we know how to differentiate powers. We have f of w equals, we're going to break it up as follows. We're going to write this as 1 over w cubed plus, and then w over w cubed plus, and then w squared over w cubed. And now we're going to simplify a little bit. So f of w is equal to 1 over w cubed. Here we have w over w cubed, so we're going to lose one copy of the w. So we'll have 1 over w squared. And the last term here is w squared over w cubed, so we'll lose 2 copies of the w. So we just have 1 over w. Now what we can do is we can take all of these w's and we can bring them upstairs so that the exponents become negative. And so we have w to a power. For example, 1 over w cubed, when we bring the w cubed up to the numerator, it'll become w to the negative 3. Plus 1 over w squared, when we bring up the w squared, it'll be w to the negative 2. And 1 over w, when we bring up the w, it'll be w to the negative 1. And now we're ready to differentiate because we have w to a power. So f prime of w, using the power rule, you have to be careful when you have negative exponents. Remember, we're subtracting. So we'll bring down the minus 3. And we have w, and then minus 3 minus 1 is minus 4. A very common mistake is people will add, because most of the time you have positive numbers, so it's easy to mess up. Here we can bring down the minus 2. We have minus 2 w to the minus 3, you subtract 1. And then for the last term, w to the negative 1, we bring down the minus 1. And then minus 1 is minus 2. And so f prime of w would be minus 3 times w to the negative 4 minus 2 times w to the negative 3 minus w to the negative 2. I hope this video has been helpful. Good luck.